Okay, so I'm going to be going over electronegativity and kind of what kind of trends you'll see on the periodic table and how you can use this, and also some practice problems and some notes you can take over them. So, electronegativity is going to be the measure of how easily an atom attracts a pair of electrons to form a chemical bond. So, a higher electronegativity value will mean that an atom readily attracts electrons to form a chemical bond with another atom in a covalent bond. So, a lower electronegativity value means that an atom readily donates electrons to form a bond or it's electropositive. So, we can see in this example that the bond between hydrogen and chlorine is a polar covalent bond because there are positive and negative poles. And what this is kind of showing is that hydrogen is more weakly attracting the electrons that they're sharing in the middle to its nucleus. So since it's weakly attracting, that means it has lower electronegativity. And because chlorine is more strongly attracting the electrons to its nucleus, it's going to have higher electronegativity. Oh, so on the flip side, the bond between fluorine and fluorine is going to be a non-polar bond, and that's because they both equally attract their shared electrons in the middle right here. So they both have a point one. If they both have a point one, if fluorine has a point one charge, then the other fluorine is going to have a 0.1 charge. So because there's no negative pole or no positive pole, and they're both equally attracted, it's going to be a non-polar bond. So some of the trends you can see with electronegativity that you're going to need to know for your tests and quizzes is going to be that as you move across a period, so ignore the metallic character and the non-metallic character, but as you move left to right across the periodic table, your electronegativity is going to increase because the nuclear charge is going to be increasing and the atomic size is going to be decreasing. Another trend you can see is that there's also an increase in the atomic number as you move down a group. So groups are obviously up and down. So the nuclear charge is going to increase, but the effects of the increase is overcome by the addition of one shell. So the increase in nuclear charge is going to be overcome by the addition of the shell, and so the value of electronegativity is going to decrease as you move down and increase as you move up. So the highest electronegativity that an element can have is going to be this one up here. So a few notes you want to take or just think about as you're going over electronegativity is that metals will show a lower value of electronegativity as compared to the nonmetals. Also, fluorine is the most electronegative element on the periodic table. So cesium is going to be the least electronegative element. So that one box I was showing at the top right, that was fluorine. And then cesium is going to be down more towards the lower left. Also, another thing you're going to want to note is that noble gases don't have electronegativity values. They're stable and they do not want electrons. So those are going to be ones that you're not thinking about or not taking into account. So there are a few factors that can affect electronegativity, one being the size of an atom. So a greater atomic size is going to result in less value of electronegativity. And this happens because electrons are farther away from the nucleus, and the nucleus will experience a lesser force of attraction. So, another factor that can affect electronegativity is going to be the nuclear charge. The greater value of nuclear charge will result in a greater value of electronegativity. And this happens because an increase in nuclear charge causes electron attraction with greater force. So, a few frequently asked questions revolving around electronegativity. One of them is, what is the difference between electron affinity and electron negativity? So, the difference between the two is that electronegativity is a chemical property that shows how well an atom can attract electrons to itself as the amount of energy released when an electron is added to a neutral atom. So how does the electronegativity of an element affect its bonding? So it affects the bonding of an element because elements with higher electronegativity tend to form ionic bonds with other elements. So, just a few exercises you can do to practice your knowledge on electronegativity. The first being just an easy ordering the following elements from smallest to largest electronegativity. And you just want to use your periodic table for that. So, you can pause the video or take a second just to get your periodic table and look at that. And the answer is right here. And a few long answer questions that you can look at are these. You can describe electronegativity trends in the periodic table. You can explain the difference between nonpolar molecules and polar molecules, and you can compare the location bonding electrons in a polar covalent bond with those in a nonpolar covalent bond. And you can also think about the difference between a covalent molecular solid and a covalent network solid. So, do their properties differ and explain? So, I'm just going to go over briefly each of these answers and what they would be. Um, the first being describe electronegativity trends in the periodic table. So, as we already stated, electronegativity was the measure of how strongly an atom attracts electrons um, in a chemical bond. So, electronegativity is going to increase as you move from left to right across a period in the periodic table. So, this means that the elements on the right side of the table are going to have a higher electronegativity than those on the left. Um, as for explaining the difference between nonpolar and polar molecules, nonpolar and polar molecules have different levels of electron sharing and distribution. So, in a nonpolar molecule, the electrons are going to be shared equally between the atoms. So, this is going to result in a balanced distribution of charge. And this happens when the electronegativity of the atoms are similar. So, on the other hand, a polar covalent bond or a polar molecule, there is an uneven distribution of charges due to the differences in electronegativity. So, it's going to create a partial positive charge on one end and a partial negative on the other. So, it's kind of like a magnet, thinking of the positive and negative sides. And then, as for comparing the locations, in a polar covalent bond, the bonding electrons are not shared equally between the two atoms, so they're going to spend more time closer to the atom with the higher electronegativity. So this is going to create that partial negative charge around that atom. And in a nonpolar covalent bond, the bonding electrons are shared equally, so they are going to be located right in the middle with no significant charge imbalances. So it's just like an equal sharing of electrons in nonpolar bonds. And then as for the differences between covalent solid and covalent network solid, um, a covalent molecular solid is made up of individual molecules held together by weak intermolecular forces. So these solids are going to tend to have lower melting and boiling points because the intermolecular forces are relatively weak. And on the other hand, a covalent network solid is going to be a giant structure where each atom is covalently bonded to its neighboring atoms. So these solids are going to have high melting and boiling points because the covalent bonds are strong and require a lot of energy to break. And as for if their physical properties different, they will be differing. So thank you so much, and yeah, that's all about electronegativity.